Okay, so let's get rid of this little error box again. And basically on our spider controller, we obviously need to decide how quick he's going to move. So let's create a float value for that. So a public float move speed. And like I said, we're going to have him only move as soon as he appears on the screen. So we're going to need something within our script here to control whether or not we're currently should be activated, basically. So we're just going to create a public bool. Actually, this could be a private bool because it doesn't need to be accessed by another script or anything like that. So we'll say private bool. We'll call it can move. Okay, so basically what we want to say in our update loop here is if can move is true, then we want to be able to move the spider. And much like we've done with the player, we're going to move the spider by using the power of our rigid body that we just attached to him. Now, and since we attached it, we might as well take advantage of that to be able to move our spider off to the side. So back up here again, we're going to make a new rigid body object. So we'll say private rigid body 2D, and we'll just call it my rigid body. So again, this is just because this will be the rigid body on the spider. It's not going to be any other one at all. So much like we did with our player controller back at the start, we're going to say here in our start loop, my rigid body is equal to get component, and in the sharp bracket here, rigid body 2D. And we put our brackets and our semicolon at the end. Okay, so then in our update loop, if our can move is true, so basically if we have permission to move, we're going to make our spider guy walk off to the left of the screen. And how do we do that? We just say my rigid body dot velocity is equal to a new vector tree. And much like we did with the player, we want it to move to the left on the x-axis, so we want it to be a minus value. So we want it to be the minus value of move speed, so minus move speed. His y velocity, we don't want to make any changes to that, so we'll just say my rigid body dot velocity dot y. So we're maintaining whatever y velocity we already had. And then on our z axis, again, we don't want to ever mess with the z-axis. We don't want it going anywhere on that. So we'll just put that at 0f. We know we always want any object in our world to be staying on the same z-axis. We don't want it disappearing off into the distance for no reason. Okay, so now that we know what will happen when our can move is activated, how do we activate our can move in the game? So what we know that we want it to happen as soon as our enemy appears. And there's a special function within Unity that actually controls when a game object is visible on the screen, then we can do a special bit of function with that. So much like before, when we have our start and our update, and back on our player controller, we introduced the idea of using on trigger enter, and we introduced on collision enter and on collision exit. There's another built-in function within Unity that we can take advantage of here. So we'll go down below our void update, and we'll say void on became visible, and then we put our open and close little brackets like that. And basically all this is as soon as any object in a game appears in the camera's view, as soon as that happens, it'll run whatever code we have in here. So conversely, we can also have on became invisible for whenever an object leaves the screen, but we don't want to use that now. We want to use on became visible. So basically, as soon as the player becomes, or as soon as the spider becomes visible, we want to say, okay, now the spider is visible, can move should be true. So here we just need to type can move equals true, and that's basically all we need. It doesn't matter if the spider goes off the screen. We don't need to reset it to back to being can't move, because logically, if our player sees an enemy coming at him and the player jumps over it and just keeps going, the player doesn't really want to go back and find out that the enemy just stopped moving as soon as they left the screen. It works for the enemy only to start moving when they come on, but it kind of looks weird for the enemy to stop moving when they leave. So we're not going to mess with that. So that's fine, and we're going to just save that now, and that's kind of pretty much the basics of what we got to happen in our spider controller script. So we'll go into our spider here, wait for that script to compile again in the corner, and once that's done, we'll go down to add component and add our spider controller script to the spider, and set our move speed to be 3. I think it should be fine. So now we can play the game and see what happens. At the moment we haven't actually added the hurt player script to do some damage, but that's okay, we just want to test them out first. Okay, so what happened there is he fell over in our world, which obviously that's not very good. So we need to, on our rigid body, we need to freeze his rotation, much like we did with the player, so that he doesn't fall over. So let's try this again. We'll walk over to here, he'll come on screen, and he'll start walking to the side, and then he disappears off down to the ground. So perfect. That's absolutely what I want to happen. It kind of looked a bit weird that he kind of overlapped with the ground a little bit, so we're actually going to stop that. We could actually make this our hard box collider. We could make this a little bit wider to about there. That's about fine. Yeah, that's grand. So now he won't do so much overlapping with the ground here. And we could actually, much like we've done with our spinny saw and stuff like that, we could set the layer for this guy to be behind everything in the world as well. So let's do that. We go to our sprite render and we'll set our sorting layer for him to be world objects. So now he'll appear behind the player at all times, and also behind the ground, just the way we wanted to. Okay, so let's add the hurt player script here so we can do some actual damage to the player. So our hurt player, because we have our trigger collider around the edges, we know we can actually do damage, so we'll just do 1 damage every time we hit the player. So let's walk here, walking along, and we'll hit against the side and we take some damage. So at the moment we can kind of push back against them, and that's fine. We'll kind of do some stuff to fix up that later, but now he's fallen down. He's got the same thing that used to be happening with our player, where he's sticking to the edge of the platform here, so we don't want that. So let's apply the material we made before. Although it's called the player material, it will work perfectly well for these guys as well. So let's apply this material to our box collider here, just like that, and now he'll be all slippy and slidey and he can fall off the edge like that. But what happens when this guy falls off the edge? At the moment what will happen is he'll keep just trying to move off to the left, and if he's trying to move off to the left, then that's using up game resources which we don't need to be happening. So he needs to be not doing anything anymore. So if he's going to fall off the screen, then we should take advantage of the kill box existing and use that to destroy him as soon as he hits the kill box. So let's go back into our spider controller script, and we're going to do the exact same thing we've used before and do void on trigger enter 2D, and again collider 2D other. So we're doing the same thing we've done multiple times before and just saying other.tag. Oh, sorry, this should be if other dot tag is equal to our well, it was kill plane, yes. So we need to make sure we remember the right name. So our other.tag equals kill plane, and then if our spider runs into the kill plane, basically we want to say okay, destroy our game object. So perfect, we'll save that. We got our script basically all done now. If we pop back into the game, we're going to hit play here, and now once the game gets running, if we just scroll down, we want to make sure we can see the spider in our hierarchy here. We should see, if the spider appears on screen, he'll walk over to the side, fall down, and then disappear. So he's no longer being used by the game. The game isn't wasting resources telling that spider to move to the left. He's gone, so we don't have to worry about him anymore. So perfect. That's our first basic little enemy. He's kind of a simple little guy. So let's create another enemy that, instead of just kind of wandering off to the side like that, let's create an enemy that can walk back and forward between 2 different points.